Watch the complete playlist on the app Pions. Download the app now.
Let's start with question number 1. The question number 1 says, the function is continuous from 0 to 6. Find the value of the constants a and b. So the given function is continuous from 0 to 6. Let's write few things here. From here we can get for the first one, okay, this is our LHL for 2 that exists here, and this is RHL for 0, right hand limit for 0. This is our left hand limit for 4 and the right hand limit for 2. This is our right hand limit for 4 and left hand limit for 6. Now as we can see that there is RHL for 0 but there is no LHL for 0, and there is LHL for 6 but there is no RHL for 6. Hence we will skip these two limits. To check the continuity or to prove or to get something, we should have LHL as well as RHL. Okay, so first of all let's start with our LHL, okay, for 2. So let's start at x equals to 2. So at x equals to 2, limit x tending to 2 negative. Let me remind you again, 2 negative means left hand limit, not minus 2. Be very careful with this. Limit x tending to 2 minus f of x. Now which function will be called for 2 minus? 2 minus is left hand limit. So our first function will be called, and this will be limit x tending to 2 negative x square plus ax plus b. Now if I put here 2, be very careful, you don't have to substitute minus 2, you have to substitute 2 only, because it is 2 negative means left hand limit of 2. So it will be 2 square plus 2ax, x I have already substituted 2, so 2a plus b. Substituting x as 2, it will be 2 square plus 2a plus b. So 2 square will be 4 plus 2a plus b. Equation number 1. This is our left hand limit. Now let's see the right hand limit. Since the function is continuous, left hand limit should be equal to right hand limit. So let me write here separately x tending to 2 plus f of x. Now 2 plus f of x. F of x is this one, because this is your right hand limit for 2. So this function will be called, and limit x tending to 2 plus 3x plus 2. Let's substitute here x as 2. So it will be how much? 3 2s are 6 plus 2. So that is 8. That is equation number 2. Let's equate the left hand limit equal to right hand limit for 1 and 2. So we will get 4 plus 2a plus b, and that will be equals to 8. So 2a plus b must be equals to 8 minus 4. So 2a plus b must be equals to how much? 4. Equation number 3. Correct? Let's move to our 4. Okay. So x equal to 4. Let's simplify. So at x equal to 4, at x equals to 4, okay, limit x tending to 4 negative f of x. Let's go back to our function and see which one is limit x tending to 4 negative. So which is this one. This is our left hand limit for 4. I hope this is clear. So left hand limit for 4 is 3x plus 2. Let's substitute here. So limit x tending to 4 negative 3x plus 2. Putting here x as 4, this will give you 3 into 4 plus 2. So 3 4s are 12 plus 2, 14. This is the left hand limit for x equal to 4. Let's solve for the right hand limit over here. So limit x tending to 4 positive f of x. 4 positive means right hand limit on the right hand side of 4. And what is there on the right hand side for 4? What is the function? 2ax plus 5b. 2ax plus 5b. Let's put it here. So it will be 2ax plus 5b. Limit x tending to 4 plus. Let's substitute here 4. So it will be 2a into 4 plus 5b. 4 2s are 8a plus 5b. Now let's equate left hand limit and right hand limit. So here it will be 8a plus 5b. That will be equals to 14. This is our equation number 4. Let's go back to our equation number 3. Equation number 3, as we can see over here, it is 2a plus b equal to 4. So let's write here 2a plus b equal to 4. Now, let's multiply this equation 3 with 4. So this will, the whole equation I am multiplying with 4. Why I am multiplying? So that we can do elimination method. 4 2s are 8a plus 4b equals 16. This is our equation 5. Let's subtract 4 and 5. So let's write it here. Let me write it over here only so that we get enough of space. 8a plus 5b equal to 14, and 8a plus 4b equal to 16. So 14 minus 16, okay, 5 minus 4b, this will give you how much? B. 14 minus 16 will give you minus 2. Let's substitute this b in our equation number 4. So this equation number 4 will give you 8a plus 5 into minus 2 equals 14, or 8a minus 10 equals to 14, and 8a will be equals to 24. So a will be equals to 24 by 8, which is equals to 3. So a is 3 and b is minus 2. Let's move to next question, question number 2. Question 2 says, find the values of a and b if the given function is continuous at x equal to 0. So as we can see, this is our left hand limit, this is our central limit, and this is our right hand limit. If the given function is continuous, then the left hand limit must be equal to the central limit, and that must be also equal to the right hand limit. Let's start with left hand limit now. So for left hand limit, so LHL, limit x tending to, we have x tending to 0 negative. So this will give you sin x into log x, log 1 plus ax whole divided by 2x square. This is our LHL function. Now, let's simplify it. So we can write it, this function, as limit x tending to 0 negative sin x upon 2 times x into log of 1 plus ax upon x. I have splitted this x square as x into x. We can multiply them, right? So I took one of the x below the sign, another function below log. Now we know that sin x upon x is how much? 1. So we left with half here, and log 1 plus kx upon x is k. So k here is a. Let me repeat here. For x tending to 0, sin x upon x is 1. And log 1 plus kx upon x, k is a. So a by 2. This is our left hand limit. So if left hand limit is a by 2, we can put it equal to the central limit. So a by 2 must be equal to 1 by 2. And this implies a must be equal to how much? 1. A is equal to 1. This is our a value. Let's solve for the right hand limit. So RHL for right hand limit, limit x tending to 0 positive. This will give you 1 minus root under cos bx whole divided by 2bx square. Correct? Now here we have root. We don't have direct formula for roots. So what we will do? The best option is to rationalize. Whenever you have root and you don't have any other option to simplify, simply rationalize. That will help you a lot. So 1 minus cos bx into 1 plus cos bx, 1 second, 1 plus root cos bx whole divided by 1 plus root cos bx whole divided by 2bx square. Okay. Now when you multiply 1, the numerator, 1 minus a minus b into a plus b, a square minus b square. So when you b square it, you get the removal of this root. So there is no root here. Okay. Again, I am repeating, a minus b into a plus b, it will be a square minus b square. 1 square is 1, and square of this root, the root will go. Whole divided by 2bx square into, this will be 1 plus root under cos bx. I hope this is clear up till here. Limit x tending to 0 plus. Okay, let me take it to the next page. So limit x tending to 0 plus 1 minus cos bx whole divided by x square into 1 plus root cos bx. This was our outcome. Let me confirm it again. So let me scroll up. Yeah, here there was extra 2. Rest everything is fine. So there is a extra 2 here. So 1 minus cos bx and 2b is there. 1b is also there with this. So 1 minus cos bx upon 2bx square, this thing. Again, even if you put here now 0, you will get cos 0 as 1, 1 minus 1, 0 upon 0 you are getting. So be very careful. Simplification is must whenever you are getting 0 by 0. So 1 minus cos theta. Let me remind you half angle formula. 1 minus cos 2x. Pay attention. 2 sine square x. 1 minus cos 2x is 2 sine square x. What if the angle is divided by half, like 1 minus cos x? I divided this 2x. Angle, when you divide it with half on the left hand side, it will become half on the right hand side. Similarly, if it is cos bx, this will become 2 sine square bx by 2. Be very careful. Let me remind you, here this is cos 2x, 1 minus cos 2x. So 2x here makes it x here. So when it is x over here, it must be divided by 2. So divided by 2. If it is bx, it will be bx by 2. Sir, what happens if it was 1 minus cos 4x? If it is 1 minus cos 4x, straight away 2 sine square 2x. So whatever is the angle here, divide that angle with half here and you will get corresponding half angle formula. So I hope this is clear, though this is done last year in 11th standard in trigonometry. So I'm just removing this part. And let's come back to our problem. So 1 minus cos bx is nothing but, okay, simplifying that, it will give us 2 sine square bx by 2 whole divided by 2b x square. And you have this parameter. You don't have to worry about this parameter because this is anyways giving you, it will not give you 0 because there is a plus in between, and cos, when you put x as 0, it will give you 1. So don't worry about this bracket term. Let's simplify the other terms. So this will be limit x tending to 0 plus and sine square. Let me make it simple for you. Sine bx by 2 into sine bx by 2. Sine square means sine bx by 2 upon sine bx by 2 whole divided by bx square. So let me just keep this b outside, and x square I am taking here x into x. Later we will pair it up, and here we left with 1 plus root under cos bx. I hope this is clear. Clear? Now bx here. Now what we want here, see, our formula is sine x upon x must be 1 limit extending to 0. So if instead of x, if it is 2x, here you need 2x. If it is sine y, here you need y. If it is sine 40, you need 40, and so on like that. Okay. So eventually what will be the angle? The same for limit x tending to 0. Be very careful. Okay. That 40 is not a proper way of saying this, but if you have a variable, the variable should tend to 0. So here limit x tending to 0 positive sine bx by 2, pay attention now, upon bx by 2 into bx by 2. What I am doing? I am rationalizing into sine bx by 2, bx, only bx by 2, not the whole thing, bx by 2 upon bx by 2 into bx by 2 whole divided by, we have one b already there, x and this bracket term 1 plus root under cos bx. I hope this is clear. Let's cancel this x with this x with that x. Let's see what we left. This putting the limit will give us 1. This putting the limit will give us 1. And here this cos bx root of 1. Root of 1. Let's see what we left with after putting the limit. So first we left with b by 2. Sir, which b by 2? Here, this one. This b by 2 we left with. Then we left with this b by 2. So let's put here into b by 2. Then we left with an extra b in the denominator. Correct? And 1 plus cos, that we left with 1 plus root of 1. Root of 1 is 1. Let me repeat again. Root of 1 is 1. So this will b cancels with one of the b, and you left with b upon 4. 2 2s are 4, whole divided by 2. So that will give us b by 8. B by 8 we got our right hand limit, and that should be equal to the central limit, which is half. So let's substitute here. B by 8 equals to half. B by 8 equals half. And putting 8 on the right hand side, it will give you 8 by 2. So our value of b is nothing but 4. So value of b here in this problem is 4, and value of a is 1. Done. Great. So let's move to our next question. Find the value of k for which the following function is continuous at x equal to pi by 2. Now see, listen very carefully. Sometimes instead of saying less than equal to or greater than equal to, they give you like this: x is not equal to pi by 2. So you don't have to get confused. That's why they have not given less than or greater than or LHL or RHL. See here, LHL and RHL both is this. Both of them is this, right? Like if you choose a number line and this is your 1, all the numbers on the left hand side are less than 1. All the numbers on the right hand side is greater than 1. So all these numbers are not equal to 1, correct? So this x not equal to pi by 2 means all the values other than pi by 2. And x equal to pi by 2 means our central limit. Now what we will do? Limit x tending to pi by 2. Let's solve it for LHL as well as RHL. Doesn't matter what you put here, plus or minus, because anyways both are same. The same function is called. So limit x tending to pi by 2, k cos x whole divided by pi minus 2x. Now what happens when you put pi by 2? When you put here pi by 2, cos 90 is 0. And when you put here pi by 2 and 2 cancels, pi minus pi 0. So you are getting 0 by 0 format. Now when you are getting 0 by 0 format, what can you do? You can rationalize, you can use formulas, or you can substitution method you can do, right? So let's use substitution method and substitute. Let y or t or your wish, you can choose any variable. Let y equal to how much? I am choosing y equal to our x minus pi by 2. Okay. Now the question is, sir, how do you know what to substitute? Listen very carefully. If I am choosing y equal to x minus pi by 2, putting x as pi by 2 in this will convert it into 0. Let me repeat here. If x is pi by 2 in this particular equation, y will tend to 0. Then I can apply the identities here, because we don't have identities for x tending to pi by 2. We have identities for x tending to 0. Sin x upon x is 1, cos x upon 1 minus cos x upon x is there, tan x upon x is there. All those are true only for x tending to 0. So somehow I am converting the limits. Putting here x as pi by 2 minus pi by 2 will be 0, and y will be 0 in that case. So if that is the situation, let's take pi by 2 on the left hand side. Y plus pi by 2 will be equals to x. And let's substitute here limit x tending to, now I am choosing y now, because substitution. Y tending to whom? 0. Sir, how you got 0? Again I am repeating. Put here x as pi by 2. Y will be 0. Sir, what if I substitute and don't change this limit? The whole problem goes wrong. You can try that. So if you are substituting, then you have to change here this value also, which is the major problem with the students. They do substitution, but they don't change this value. Cos x will be what? Here it is written y plus pi by 2 or pi by 2 plus y. Let's write it like this. A plus b same as b plus a whole divided by pi minus 2 into x. X is how much? Y plus pi by 2. Great. So this will be limit y tending to 0, k cos 90 plus theta. 90 plus theta lies in which quadrant? Second quadrant. Cos 90 plus theta lies in second quadrant. Okay. And cos is positive or negative in the second quadrant? Sir, cos is negative in the second quadrant. Cos is negative in the second quadrant. And cos will switch into sine. So sine y. 11th standard trigonometry, cos 90 plus theta is minus sine theta whole divided by pi minus 2y and minus pi. When you multiply this 2 with this 2 cancels and you left with pi. Let's cancel this pi with pi, and this will give us limit y tending to 0. Be very careful. Minus k sine y upon minus 2y. Let's cancel this minus with minus, and you left with limit y tending to 0, k by 2 sine y upon y. What is sine y by y for limit y tending to 0? That's 1. So you left with k by 2. And this must be equal to the right hand limit or the central limit. So here this is central limit given, so that will be equal to 3, and this implies k is 6 here. Be very careful. Let's move to next problem. Now, till now we had already given that questions in which we had the functions were continuous. This is our next problem. It says check the continuity of the given function, and the function is given. So we have to check if LHL equals to RHL. If it is so, then it is continuous. If it is not, then it is not continuous, right? So let's start with our first one. This question, f of x is equals to x square sine 1 by x for x not equal to 0. Let me remind you once again, not means both LHL and RHL. So in this question, we have to check LHL, RHL with the central limit. So here limit x tending to 0, okay, x square into sine 1 by x, correct? Now if I put here x as 0, it will be 0 into sine 1 by 0, which is not defined. So 0 into not defined, okay, and determined form. So first what we will do, we will rationalize this term. So let's rationalize it, 1 by x into 1 by x. Now this will be rewritten as limit x tending to 0, x square upon this x I am writing below here, into sine 1 by x divided by 1 by x. X cancels with this x. Now you're left with limit x tending to 0, x into, you have to write in every step limit x tending to 0 till you substitute it every time. And when you are substituting, in all together you are substituting. So when you are substituting here, sine 1 by x upon 1 by x, that's 1. And 1 into this becomes 0. So answer here is 0. Sir, can we have answer as 0? Yes, but you can't have 0 by 0. Be very careful. So the left hand limit or the right hand limit is giving you 0, and the central limit is also giving you 0. So is the function continuous at x equal to 0? Yes. The above function, the given function is continuous at x equal to 0. Done. Let's move to next question. So here is our next question. Question says find the value of a and b such that the following function is continuous. So let's see how to figure out the values of a and b. So when x is less than 2, this is our LHL for 2. This is our LHL for 10. This is 2. And RHL for 2. And this is RHL for 10. Right hand limit for 10. Right? So let's start with 2. So for 2, limit x tending to 2 negative f of x. Now here there is no function of x itself. The value of the function itself is 5. So this will be 5 only. Correct? Okay. Next. Let's see this is our LHL. Let's see the RHL. So for right hand limit x tending to 2 positive f of x, that will be equals to limit x tending to 2 positive ax plus b. Now putting here x as 2, this will give you 2a plus b. Now put LHL equal to RHL. 2a plus b must be equals to 5 because the question is saying it is already continuous. So this is our equation number 1. Let's see the left hand limit for 10. So LHL limit x tending to 10 negative f of x, that will be equals to limit x tending to negative 10 negative, and what is f of x? Ax plus b. Putting here 10, this will give you 10a plus b. I hope this is clear. Now let's see the right hand limit. RHL is equal to limit x tending to 10 positive f of x. And what is f of x here? Directly 21. So this will give you the 21 value. Let's equate the left hand limit with the right hand limit for 10. So 10a plus b equal to 21. This is our equation number 2. Let's multiply equation number 1 with 5. So this will become 10a plus 5b equals 25. And let's subtract it from the equation number 2. So 10a minus 5b minus 25. Cancels. Minus 4b minus 4. B equal to 1. Let's substitute the value of b in the first equation. So from first equation, 2a will be equals to 5 minus b, and a will be equals to 5 minus 1, 4, 4 divided by 2, which is 2. So a is 2 and b is 1. I hope this is clear. Let's move to next one. Our next question says, for what values of k is the following function continuous at x equal to 2? So this is our left hand limit for 2. This is our central limit for 2, and this is our right hand limit for 2. Correct? So first of all, limit x tending to 2 negative f of x. So I am doing for LHL. So limit x tending to 2 negative, and what is our f of x? 2x plus 1. So let's put here 2x plus 1. Now putting here 2, it will give you how much? 2 into 2 plus 1. 2 2s are 4, 4 plus 1, 5. This is our LHL. And putting this equal to central limit, our k value here will give you 5. Okay, let's confirm it with RHL also if you want. So RHL is nothing but limit x tending to 2 positive f of x. Now putting here 2, this will give you limit x tending to 2 positive into 3 into 2. Okay, 3x, let me write the function first, 3x minus 1, and this will give you 3 into 2 minus 1, which is 5 again, and that is equal to central limit. So again, k is 5 for both LHL and RHL. Let's see the next question. The next question says, find the value of a if the following function is continuous at x equal to 0. We have to find the value of a for which the given function is continuous at x equal to 0, which means LHL must be equal to the central limit and RHL must be equal to the central limit. Let's start with LHL. So limit x tending to 0 negative f of x. This will give us limit x tending to 0 negative. What is our f of x? Sir, 1 minus cos 4x whole divided by x square. Now 1 minus cos 4x. Okay, let me remind you, half angle formula, 1 minus cos 2x is 2 sin square x. So if we double the angle here, this angle will also get doubled. So 1 minus cos 4x must be equal to 2 sin square 2x. Be very careful with this. Okay, so if you double the angle on the left hand side, the right hand side angle also get doubled, not the whole value. So this will give us a limit x tending to 0 negative 2 sin square 2x upon x square. Correct? Let's separate them and make it simple. Limit x tending to 0 negative 2 sine square. Let's make it as sine 2x upon x into sine 2x upon x. Let me explain. Sine square 2x is sine 2x into sine 2x, and x square denominator is xx. Is it equal to 1? No. No. First you have to get here 2 and here 2. So how many 2's? This 2 into 2. So here I am multiplying with 4. Let me repeat again. I multiplied here with 2 and this 2. 2 2's are 4. So this gives us 4 here. Means rationalized it. Let's keep it in bracket now so that you can understand that sine 2 theta upon theta, 2 theta with theta tending to 0 will be 1. So this is 1 and this is 1. We left with how much? Our left hand limit is 8. Clear it is? So if the left hand limit is 8, so let's put it equal to the center limit, which is a. Clear? Done. But let's solve the RHL part also. What if in exams they give you some other thing like this? Okay, then how to simplify this? So let's write this function for RHL here. Limit x tending to 0 positive, and what's our function? Root x upon root under 16 plus root x minus 4. Let's confirm it. Yeah. So if I put here 0, root of 0, 0, okay, root here 0 and 16 root is 4, 4 minus 4, 0 by 0 form you are getting. So what you have to do if you have roots? Sir, rationalize it. Root of 16 plus root x plus 4 whole divided by root of 16 plus root x plus 4. Great. Now this is a and this is b. A minus b, a plus b. So what is a plus b into a minus b? A square minus b square. So limit x tending to 0 plus root x into this will be root of 16 plus root x plus 4 whole divided by a minus b into a plus b. A square, correct, minus b square 16. Let me repeat again. This whole thing square will, this root will go, not this under root x will go. No. So this when you open 16 and minus 16 cancels, you left with limit x tending to 0 root x into root under 16 plus root x plus 4 whole divided by 16 and 16 cancels, you left with root x. Let's cancel this root x with this root x and put the limits. It will be root under 16 plus 4 and root 16 is 4. So 4 plus 4 which is 8. Even the right hand limit is giving you equal to the center limit which is a equal to 8. Done.
Watch the complete playlist on the app Pions. Download the app now.